On Wednesday afternoon session, we discussed how to apply Latin square design. And if I recall very well, the last part that we did, it was to construct an ANOVA table, which we did, and then we managed to find the figures as indicated from the board here. And when you test, I hope you can see that when you test, nothing is significant, right? When you check the tabulated value of 2 and 2, you will find the value being 19. The value here is 19.00. So if you can check, it means that based on that value, there is no difference between treatment means. Blocking by row was not effective. Blocking by column was not effective. So I will suggest that we come up with another example. I have another example ready for you. We do the same process. From there now we do the, because for us to do pairwise comparison, we need the treatment to what? We need to reject when testing for the treatment for us to do pairwise comparison. So based on this example, it's not possible to, or it's not necessary. It's not necessary to do pairwise comparison. It is possible, but it is not necessary. So I have another example here, which we can do. But again, I was so disappointed from the first test when you're given, I asked you a question to give me the model of the model, but most of you guys, you fail to write the model, and that's, if you fail to write the model, it means you don't understand what you're doing. So it is very, very important to know how to write the model. For example, Latin square design model is given by y I j k, which is equal to you must understand again the meaning of this. So you know that we must have the population mean. So to know how many parameters are needed, you'll be guided by what you are going to test. Remember, for Latin square design, we agreed that you will have the rows. You have 2 blocks, right? Or let me say 2 blocks, which is what? The rows and columns. You know what's happening now. And the what? The treatments. And remember, we don't have what? The interaction effect. So it means you need three Greek letters to represent all these things that we'll be testing. You need a Greek letter to represent this one. Rows, you need a Greek letter to represent the columns. You need the Greek letter to represent what? Represent the treatment. So the model can be written as plus rows. You can say I rows. That what means this goes with the rows, plus Now we want something that can represent the columns. We can say beta j. This is the columns. The second one here, the second express thing here, subscript here. The last one now, what k goes with what? K goes with the the treatment k, isn't it? Because we have three things and then the errors. You see, so you must understand how to write the model based on the design that you are dealing with. So you know that this one is for rows. Rows are covered. This one are for the what? Columns. This one is for the treatments. And then you must indicate the what? You must indicate the range of your thing here, the subscript here. You must indicate that I moves from what? From 1, 2, 3, up to what? You must indicate the thing here. Same applies to J. J move from what? 1, 2, 3, up to certain thing here. And then now the last one is K. K ranges from 1, 2, up to what? This information is there in a study guide. And again, whenever you're preparing for our assessments, never ignore the study guide. Because some of the information is from the study guide. For example, the advantages and disadvantages of all these designs. The information is there in the study guide. So you cannot claim that we didn't teach you while it is there from the document that you are having. Whatever we're doing in class is the summary of the study guide. So it means you still have to go to the study guide and check some of the things there. So let's go to uh, uh, I want us to do a certain example. That one I checked it, it will allow us to do pairwise comparison. So allow me to share the notes now. Uh, Sorry for that. Trying to share the notes. So I will want you guys to do this example with me. First of all, I want you to copy the values down so that I can branch back to the. I will branch back to the what the. Oh, it's fine. It's fine. I want us to do example 2. Example 2 is related to that problem that we have been doing since uh, we started with chapter 3. Remember when I introduced chapter 3, I gave you an example of um, 4 types of cars and the position of the wheels and the brand of the tires, right? So this is now, if we look at this design now, it qualifies to be a Latin square design. Why? Because all these things are covered. If you check, how do you check if something is a Latin square design? You need these general properties of a Latin square design. When you check that problem, there are 2 blocking variables from that example. What are they? Let's check them. We're saying that 2 blocking variables. Let's check them. We're blocking by car and the position. So the first one is covered. Let's go back. In general, rows blocking variable and column blocking variable. So the first property is covered. These are the three general properties of experimental design. Two blocking variables, you block by rows and you block by the columns. B, the number of level of row blocking variables is equal to the number of level. The number of level of blocking variable is equal to the number of column blocking variable, which is also equal to the number of treatments. What do we mean by this? Let's go back to the example. The levels now, you have focus, it's indicated here. Now you have focus, and again you have what? 4 positions, and the last one is what? 4 treatments, which is what? A, B, C, D. So the number of levels are equal for rows, row blocking, column blocking, and the number of treatments. Let's check the last property. Latin square design can be repeated with additional experimental units to obtain more replications on the treatment. This will be covered. This will be covered in the next section. I think it's in the next section. Yeah. So the Latin square design, you can have values replicated from each and every cell, but you don't check for interaction. So values for Latin square design can be replicated uh, in each and every cell. So you can have more than one. It's possible to have more than one values in each cell, but you don't check for the interaction effect with the Latin square design. So check the disadvantages from the study guide. So can someone help me to do the addition and whatever here? Let's complete this table, guys. Let's find the sum of the positions, and again, um sum of the totals and the treatments. I will write the treatment now. So let's do this example together. Let's repeat what we did on Wednesday. It will also help those who decided not to come to our Wednesday class. Let's get the totals. Uh, I have to point here. My members are here. Um, Timekeeper, Ramaila, please you'll give me the sum of the treatments. Your focus is on the treatments. Focus on the treatments. Give me the sum of A, the sum of B, the sum of D, and the sum of C and D. Tato, Sirare, give me the sum of the cars. The sum of the cars. Nomvela, give me the sum of the positions. Nomvela, you give me the sum of the positions. You can, if you don't want to write, you can simply indicate from the chart there. So Nomvela, you will help me with the sum of the positions. Tato, give me the sum of the cars. And the last one I said is Ramaila, give me the sum of the treatments. Yes, Tato?
113,
113,
91,
91,
108,
108,
83.
83.
Yes.
So when you add when you add these figures, the whatever you get when you add the totals for the cars, your answer should be the same as when Novella add the totals for the positions. Novella, please give me the sum of the positions.
121.
Wait, 121,
124.
124,
71.
71,
And 79.
79. Again, when you add your totals, the final answer should be the same as the answer from Tato. Musibudi, give me the sum of the treatments.
Sir, can you hear me?
Yes. Yes.
Okay, for A it's 103.
103.
And then for B it's 84.
84.
Sir, sorry.
Yes.
For position 1, it's not 121, it's 131.
Oh, I'm going back to Novella. This one.
No, it's
131.
correct to say. It's 121.
Novella?
Yes, sir, it's fine. It's correct.
Oh, it's fine. Thank you. Sibudi, let's continue. Sorry for that, Sibudi.
Oh, for C 64.
C64.
And then
Last one, D.
89.
89. When you add your totals, what are you getting, Tato?
$395.
Musibudi, when you add your totals, what are you getting? Novella, when you add your totals, what are you getting?
395.
It's Novella, right? Musibudi?
So I think I made a mistake on C.
It's fine. Correct it.
Yeah, it's 119.
When you add your totals, what are you getting?
$395.
Thank you. You see, you are all getting the same figure, right? So it's very, very important to confirm if when you add the rows and when you add the values from the rows, the total, sorry, the rows, the column, and the treatment, you have to get the same value. So we're done with that first point. So now let's do this exercise that we did on on when on Wednesday. So before we can go to that, can someone give us the square all the values? Can someone square all the values? Because that is the other information that we will need. So that I want to go to the whiteboard now, because it's quicker that side compared to when we're writing from this side. What is double summation of yij squared?
10685.
10685. Like this,
Yes.
Okay, thank you very much. Let me write so that those so that others can follow. You just square all the values, right? 86 squared plus up to the last one, which is 14 squared. Can someone confirm the value from home?
Yeah, it's correct, sir.
Thank you very much. So you must have this value, guys, because we'll need it when we want to find the sum, the total. He's saying let me increase the font here. So yes, when you square all the values from the table, guys, you will get that value there. So now you must have this value somewhere, especially the totals. Now what we'll need the total for the car, total for the position, and the totals for the treatments and this value. I want to move to the whiteboard. Can you please copy these values? Not strictly the table, just have the totals for the cars, totals for the treatment, so the positions, and total for the treatments. And that's 10685. I want to move to the whiteboard. So while others are still copying, I want you to answer the first question. I want you to answer the first the what? The first question based on the given problem. Give the write the model of the given problem and explain the parameters. Write the model for the given problem. So the first thing that you have to do is to must identify the type of the design, isn't it? The design is what? It's a Latin square design. And again, now you must write the model down, explain or define each and every parameter, including the error. Are you done copying? Can I move to the whiteboard, please?
Yes, sir.
That whiteboard now. This chapter is the easiest chapter. So now, what you are asked to do for that question is to write the following. Can you see my whiteboard?
Yes, sir.
Yeah, you must indicate that the model is given by this, and then when you want to define the range, you must indicate that you have how many cars? You have 1 to 4, isn't it? And then how many blocks do you have? 1 to 4. How many treatments do you have? 1 to 4. So the shortcut is you can simply say I is equal to 1 to 4. J is equal to 1. The dash on top of the 1, it means up to 4. K, 1 up to 4. So you are defining, but you are not done. What about the subscript? That question, you are also asked to define this subscript. You must also define the parameters. Sorry, you must also define these parameters, including the error. You must indicate that the errors are normally distributed around the mean of 0 and sigma squared. You must indicate. So when you ask to define the model, you must define all these things. The example is there in your study guide or the procedure of defining. So now let's go back to our example. This is what recapping what we did on Wednesday. So we should not spend more time. So for the rows, what are we having? Tato?
One three.
113.
91.
Okay.
108.
108.
And 83.
83. And then you said the total is 395 or 385.
395.
395 or 38.
395.
395. This is the overall total. So, Novella, can you please help me again with those values?
121,
121,
124,
124,
71,
71,
and 79.
79.
Yes.
The last one is the treatment. Somebody help us fast, Yana.
103 for A.
103,
84,
84,
119,
119,
89.
89. And then now let's do the calculation. SSO. So give us that double summation. Omu?
10685.
10685, right?
Yeah.
So let's do the calculation, Omu. Let's go. Find SSTO. You will say the value from Omu minus 395 squared over T squared, isn't it? 10685. Why am I squaring this one now? See now? These values are squared, right? So what I'm doing now is wrong. Let's calculate, Omu. Can you please help us with the total?
933.4375.
9.
Yeah. 33.4375.
Can someone confirm the value?
That's correct.
Thank you. So this one, SS row. Remember last week we said you go to the totals 113 squared plus 91 squared, 108 squared, 83 squared. You divide everything by what? By T. How many treatments do we have? We have 4.
Oh,
Minus 395 squared over 16. What is the answer? So please, another group, can you please use the same procedure to find
149.1875.
149?
Point 187.
SS column. I won't write the values. Can you please give me the answer? The values are there. And the SS means SS treatment. Let's do it quick, guys. Let's go fast.
573.1875.
5.
Yeah.
Five, 7, 3, like that.
Yeah. 0.1875.
And then the treatment.
185.1875.
185.
Yes, let's go. I'm listening, guys.
0.1875.
So we're left with SSE, right? SSE, you know the formula is SSTO minus the rest. What is your SSE? Therefore, SSE is what?
$25.875.
Now let's construct our ANOVA now. We have the information. The rest we'll do it from the ANOVA table, right? Now the ANOVA is given by a source, degrees of freedom, sum of squares, MS, F, F tab. So we're going to test for the treatment. We'll test for the rows. We'll test for the blocks. And then now we have the error and the total. So let's go. The degrees of freedom of treatment and is the same for even for the rows and the columns. T minus 1 is what? To be 3, right? 3, 3. The degrees of freedom of total is T squared minus 1, which is 15, right? And 15 minus 9, I think is 6. Omu, help me with the other leaders. Help me with those sum of squares.
So aren't we supposed to have column in the source of variance?
Oh, sorry. Why did I write blocks here? The other one is columns, right? Thank you, Kendi. Rows, columns, errors, total. SS treatment, what is the sum of squares? Omu, give me the values first.
185.175.
It's for what? It's for the treatment.
It's for the
Yes.
treatment.
185.
187.
0.1875.
1875. Okay. Rows,
149.
the same 1875, right?
0.1875.
I think the decimals are the same for all the numbers. Ne?
Yes.
Okay. The columns,
573.
573.
1875. And then the total, the error, sorry,
25.865.
the total,
933. 0.4375.
complete the table, guys. Complete the table. What is left there is not difficult. Complete the table. I'm giving you 4 minutes to complete the remaining part. In the meantime, I'll check the value from the table for you guys. I'll check the value from the table. So complete the ANOVA. With that information, you should not fail to complete that ANOVA. I want us to move now. The F tabulated, I check for 3 and 6. It's 4.71, 4.76, the tabulated one. So this value will accommodate the testing for rows, columns, and the what? And the rows, columns, and the treatments. If I'm wrong, you'll correct me. I want us to move, guys. What do you have for the treatment?
61.72.
61.
Yeah, MSE. MST, I mean.
Yeah.
Yeah.
Saying what?
61. Yeah, 0.729.
Okay. Let's go.
For rows, MS for rows is 49.729.
49.
Yeah, 49.729.
Okay. So is it so for the column, is the value correct?
Yes.
Let's do the last one.
11.531. 5313.
Yes, if you can check the tabulated, your tabulated is what? So test for the rows. Okay, test for the treatments. Means we reject.
Yes, sir.
Okay, yes.
That SSTO there is 983 or 933.
The what?
SSTO, the last one on SS.
I was told it's 983.
933.
One more.
Oh, it's 933. Yeah, it is. Wait, can you see it? But it didn't affect our results, right? Because we calculated these things before using the correct value, isn't it? We calculated the SSE using the 933. Am I wrong? This one. So is the SSE affected?
No.
Okay, thank you. Let me correct it now. Yeah, let's continue, guys.
Sir,
Yes.
Your SSE is 25.875 and you wrote 25.6.8.
That's what I'm given, my brother. I write what I'm given.
It should be 0.875, not 0.865.
It means a lot of things are affected. So it means these values will be affected there.
No, sir, the values were right. The MS.
What we're using, we're not using 25.865.
Now I was using that one of 875.
So you are sure that the values are correct.
Yeah.
But I don't think this one is correct because I was using that one. So you write the correct information here. So give me the correct information and Smang, confirm them. Don't wait me to finish for me to finish, guys, and then later on you say the values are wrong. When you see that there's a difference, please just make a signal that no, there's something wrong. Don't wait for me to write and then when I was done now we say that something is wrong. Because so what is the MS?
61.72916.
61.729, right?
Yeah.
Rows?
49.729.
Columns?
191.063.
And then error?
4.313.
And then the column value for the column?
44.304.
Yes. So if we check when testing for the treatments now, you reject A0 and conclude that at least one of the treatment means differ from the rest, isn't it? At least one of the treatment means differ because of the values there. Then this is the first one. The second one was blocking effective. Was blocking effective. So it means the question means you are asked to test for rows and what? And columns because so when blocking, so you must indicate that when blocking by rows, you are testing when blocking by rows. Rows, what do you do? What is happening there? You reject A0 and conclude that blocking by rows was effective. Blocking by rows was effective. Now you move to the next one now. You have to test for blocking by column. You do the same thing. We reject, based on the figures there, we reject A0 and conclude that blocking by column was effective. It's not always the case that when you reject for the rows, you always reject for the treatment. Same applies to, or when you reject for the rows, you always reject for the columns. It's possible that blocking by column, it was not effective, while blocking by row, you find that it is effective. So it depends on what? On the values, these values. So the third one, my questions there, the ones that I created, I asked you to find, I said find the estimate of the treatment means. The estimate of the treatments. How do we do that, Mr. Medesmanga? How do we estimate the
Okay, so we're going to take each mean of the treatment, we subtract by the grant mean. So which means since
tau k hat equal to tau dot k, right? Or let me say y, sorry. Y dot k, the mean minus the overall mean. This is what we are saying, Mr. Smanga, right?
yes.
And then these are the means of what? These are the means of Means of treatments. This other one is the grand mean. How many estimates are we expecting? How many, based on our given problem, how many estimates are we expecting?
4.
4, right? We are expecting 4. So that one, we have been doing this since from what? From chapter 2. So we should not waste time on this type of questions. The fourth one, number 4, perform pairwise comparison for the treatments if necessary. Is it necessary to perform pairwise comparison?
Yes.
Let's perform. Which method do you prefer? We have got done LSD. So you want us to go with the LSD? LSD. You know you're going to compare the means of dot k minus dot k prime. If this is greater than the LSD, if this is greater than the LSD, where the LSD is given by T alpha over 2, degrees of freedom of error, double R here, multiplied by the square root of 2 MSE over T. Over T. So, give me the means of the treatments. Give me the means of the treatments so that we can continue. The means, oh, sorry. Can I get the means of the treatment? Mr. Woody, the treatments are from you, so please help us. A, B, C, D. What is the mean for the first treatment?
25.75.
25.75. The second treatment?
21.
21. Simanga, confirm the values, please.
29.75.
So 29.75. The last one, Mr. Woody?
22.25.
So now, Homer said we can use the LSD method. So let's find the LSD value. We'll say T of 0.025 provided we're using 5%. Degrees of freedom of error we said is 6 multiplied by, Omu, help me with the value, the MSE from the ANOVA table. You don't have to recalculate this, you have it from the ANOVA table.
4.3125.
Okay, thank you very much, Omu. Divide by what, guys? 4, right?
Yes.
Which is
Hey,
the
4.
value from the T table. The value from the T table is 2.447. 2.447 multiplied by that value inside it. What are you getting, guys? When you multiply everything now?
3.593.
It's what, Omu? 3 point
593.
Do the pairs now. How many pairs are we going to have? We have 4 treatments, combination 2, which is 6, right? So let's do the comparison now. Mean A minus mean B.
Sir,
Mean A, yes.
is the 4,3125 the MSE?
I'm told.
Is not 8,621.
I don't know. So, Christopher, you are coming with a different value now. Chris,
The one
where did you
from
get that one?
It's 4,3.
Hey? Chris, why are you getting yours?
the ANOVA table we were doing.
It's not 4. I think it's 4 point something. In other words, Chris, you are simply saying you got different answers.
Or maybe I made a mistake.
Yeah, can you see our ANOVA table? Do you agree with the values? The other values?
Yes.
Yeah, so check out. It's 4.31. I'm told it's 4.313 there. But I'm surprised the woman now, when we continue, now he's giving me a different value. Now he's saying, and he's the one who was busy giving me these values. Now he's saying 4.313125. That side he gave me a different answer.
Sir,
You're giving me different answers. Well,
for what, sir?
the R MSE. It doesn't matter. Let's go with this one. Let's find the differences. You have the differences from Ramayila. Yeah, the means, guys. These are the means that you need. So we're going to find the differences of these 4 means. Oh, sorry. Those means there.
4.75.
Thank you. I think the first one is 4.75, which is greater than the LSD. The second one
4.
is greater than the LSD. Third one
3.5.
3.5.
3.5, less than the LSD.
8.75. 1.25.
The last one.
7.5.
By now you know what to say when you are having this type of information. So which other method do you want to have a test? Any method do you want that you want? Let's go to student Newman Kels or Duncan. Okay, sorry. Let's say now, suppose we're supposed to use Duncan multiple range test. This is another method. I'm not saying when you're asked to do price comparison, you must do all this method. You must check which method is supposed you are supposed to apply. So step 1, Duncan, you arrange the means in order, right? Give me those means in ascending order. Just call call with the letters to save time.
29.75
Let's use the letters.
for D.
D bar.
No, it's for C.
So this is wrong.
C is, yes, C is 29.75.
C bar, let's go.
How
A
can
bar.
it be?
Sorry?
Sir,
How can it be? How can it be?
I'm listening.
I think we start with B.
Say
sir, are
the
we supposed to start with the smallest one?
Yes,
smallest.
ascending order
Yeah, it's
The first
B
one
bar.
is B.
is B.
Yeah.
B bar.
B bar followed by what?
A bar.
D bar.
Someone say A, someone say D.
D.
Is D.
And then
A.
A, C.
A.
2. Let's find the standard error of dot K, which is given by the square root of MSE over T. What would be the answer? The square root of, I'm told is 4.313. Do the calculations, guys. 1.46.
Yeah, 469.
Okay. Step 3 and 4. So now what you can do, because now you are used to the method, right? You can simply, instead of splitting the steps,
No, it's
you can say,
1.03.
can someone help me? Which one is correct?
1.0.
1.03.
1.038.
Okay. Thank you. 1.038.
038.
38.
Yes.
Okay. No, when someone get a wrong answer, it's not an issue because the person is also learning, isn't it? You can see this mistake while in class than doing this mistake in the test. So it's fine, guys. Don't attack someone if the value is not correct. So now we know what we need. How many ranges? We need 4. We need 3, right? So we'll have R2. So you can combine step number 3 and step number 4 because you know it's going to be R of 0.05, 2 and 6 multiplied by 1. Or you combine step number it's 3 and 4. 0.38. What is the value? R3. Can someone help us with the value from the Duncan? Anyone with the value? The values from the Duncan's table. I have the numericals here. Can someone help us with the values from Duncan? No one.
The value for R2.
Yes. I'm waiting for the answer.
3.46.
And then before you multiply it with 1.08, right? 0.38.
Yes. Yes.
The second one, the second value, give us the values.
4.34.
Someone is saying 3, someone is saying 4. Guys, let's go.
4.34.
No, so it's not 4.34. It's 3.587.
Yeah.
Is it the final answer or it's fine?
The Duncan
You know what
rate.
you know what you can do? Can you please give me the final answer? Give me after multiplying with that 1.038. Maybe when I ask you to give me the value only from the table, I'm confusing. Just get the value, multiply it with 1.038. Give me the final answer of R2.
3.593.
Wait. 3.
3.593.
The second one. I know
3.723.
you know how to use this table. You should not stress about that one.
3.788.
Can someone confirm the values?
Yeah, they are correct. Sir.
Thank you. Now we did the comparison. We do the comparison, isn't it? We know how many comparisons are we having? 6, right? So you say B bar minus D bar. Oh, sorry. Now I'm C bar minus B bar. And now you do the comparison. Compare this with R4, R3, R2. Compare the first pair there. Now A bar minus B bar. You compare this with R3, R2. The last one is D bar minus. You compare with R2. Give me the signs, guys. C bar minus D bar, is it greater than or less than? B bar. C minus B
It's great.
is greater. Let's go to the second one.
It's also great.
Okay. The third one.
Great.
The fourth one.
Great.
Guys, are you still there?
Less.
The last one.
Less.
You know what to say when you have that type of information. So this is how you do what? This is how you do you perform the LSD. You deal with the LSD list Latin square design problem. Is if you have noticed that constructing an ANOVA table is the easiest. It's easy because you know that the degrees of freedom of, if you are given the degrees of freedom of treatment, it means you know the other degrees of freedom, isn't it? These two. Because when you have 4 treatments, you know that you also have 4 rows and 4 columns. So those are some of the things that you have to understand. That we are talking about a T by T design. It's a square. So now remember this chapter that you covered with Mr. Delvaux that it is possible that you can be given a problem with a missing observation. You can be given a Latin square design with a missing observation. For example, oh yeah, it's fine. I'll share the notes. The notes are there for you guys. With a missing observation. Let's come up with a 3x3 problem. Let's come up with for EG. Let's say we have 3x3 problem as follows. Let's make this design balanced.
CA.
Let's make the design. It's A, right? This will be what?
No, it's CA.
It's CA.
No, I heard Omu saying A. That's why I wrote it.
No, sir, I said CA.
Let's go.
AB.
AB.
We have the values here. Maybe we have these values 2, 39, 6, 7, 2, 4, 9, right? We have a value missing here, isn't it? We have a value missing there. So let's estimate. Let's estimate the missing value. So for Latin square design, for you to estimate a missing value, you will need the following formula. M equal to T into capital letter T for the sum of the treatment, the sum of the rows, the sum of the columns, minus 2 grand mean, divide by T minus 1, T minus 2. So that is the formula that can be used to estimate a missing observation. You can use that formula there, where T indicate the number of treatments, T, small letter t, number of treatments, in our case is what? How many treatments do we have? How many treatments do we have? 3, right? And then capital letter T is the sum of the values which goes with the missing treatment. Which treatment is missing, guys? Which treatment is missing looking at this table here?
B.
Is B, right? B is only appearing 2 times, isn't it? So B is appearing 2 times. So if you want to find a value for this T here, you add the ones which are there, which is what? 6 plus 18 is what? It's 19. Because B is not there, so it means you're going to add the value for this B, because you want to estimate the value that goes with that B, isn't it? So you add the sorry, you add the two values which goes with B, because you want to estimate the B that is missing here. And then now we move to R. This one is the row where there's a missing observation. This is the row. This is the row where we have what? Where we have a missing observation. Well, let me use this one. A row where you have a missing observation. So what is the value there? 9 plus 2 is 11. C, sorry for that. So C is the column where there's a missing observation. Why in this column, isn't it? Why here? So it means it will be 4 plus 9, which is what? Which is 13. What is left? The G. The G is the grand total. Grand total. What is the grand total? When you add all the values, what are you having?
52.
52. So now estimate the missing observation. There's the information. Estimate the missing observation.
12.5.
It's what?
12.5.
12.
Yeah.
12.5. So now, if this is very, very important, you have to note it down. Our original problem was having a missing observation, right? You must get me right on this one. Your given problem was having a missing observation, which means the degrees of freedom of total will be affected. What is the degrees of freedom of total? What is the degrees of freedom of total for a normal problem? We just did that now. I wrote it some. Let me show you what I'm talking about. You see this part, guys? Sorry. Do you see this part?
Yeah.
This. Let's check this part. The degrees of freedom for total is what? Is t squared minus 2, isn't it? T squared minus 1, sorry. T squared minus 1. This is only the case if the problem is balanced. Checking at hours, our problem, this problem is having a missing observation, isn't it? Which means since the value is estimated, let me maybe write it down. Since the value of B or treatment B was estimated, therefore the degrees of freedom, the degrees of freedom of SSTO will be, maybe let me use a different color. This one is very, very important. T squared minus 2. Is it clear, guys?
Yeah.
So if you are given a problem with a missing observation, you must know that the degrees of freedom of total is no longer t squared minus 1. It's t squared minus 2. It means it will also affect what? It will also affect the degrees of freedom of error, isn't it, guys? It will also affect the degrees of freedom of error, because for you to find the degrees of freedom of error, you used to use this formula here, this one. But now it will be affected because you won't, there's no that if you use that, you will get the same degrees of freedom as when you say total minus the rest. So please, this is the only difference. Now, you have estimated HOMO that is 12.5. So maybe for consistency, because the other values you don't have decimals, if you are asked to say if the value is having decimals, round it to make it a whole number, right? You can make this one 30, but let's write the value the way it is to avoid any confusion. Because the value that we estimated is 12.5. I can write it as 13, but it can also confuse some of the leaders. So the estimated value is 12 point. Oh, sorry. It's 12.5 B, right? Because this is the one that we're trying to estimate. It's 12.5 B. So now the problem is balanced. So you can solve the problem. The other ones, they won't change except the degrees of freedom of total. The other procedure is still the same as the Latin square design, where you say for the treatment, you use the same formula. But remember, after replacing this value, the grand total will be affected, isn't it? This will change, isn't it? This will change because now we have the value there. The column total for where there was a missing observation will also change because now there's a value there. The row where there was a missing observation, now also this one will change because the value now it is there. So when we do your calculations, it means you have to redo the totals. Is it clear, leaders?
Yes.
Say repeat.
So I'm saying, recall when after estimating the value with Mr. Lebo, what did you do next? You recalculated the totals, isn't it? With Mr. Lebo.
Yeah.
There was a part where there was a missing observation when dealing with randomized block design.
Yes.
You will estimate the value. After estimating, you recalculate the totals in it for the blocks and the treatments. Same applies to this one, because now you have 12 here. You have 12. Here it is. It means the value of this row will change. So it means you need to redo the. You have to recalculate this. Do some recalculations again. You find the row, the totals for each row, and the grand total before you can do what the ANOVA. Otherwise, you are going to get wrong information if you continue with this 52, because this 50, we got this 52 before we can estimate the value. So after estimating the value, this 52 will change. The sum for the last column will change because now we have 25.5. The sum for the last row, where there was a missing observation, it will change because now we have 12.5. So that's so there's a section from a study guide where he's talking about the missing observation. So if we see a missing observation from Latin square design, don't solve the problem without estimating that value first. So if you have noticed, the only chapter where we managed to continue with a missing observation, it was chapter 2. Chapter 3, whenever you see a missing observation, you estimate it. Chapter 5, whenever you see a missing observation, you estimate it. So,
Sir,
yes,
so when you find the missing value, ne,
yes,
let's say like on this example, we got 12.5. So
yes.
are we going to write as a whole number or as a like a decimal?
Yeah, that I'm saying, like maybe you can check the other values. Are they having decimals? You can say 12.5, which is equivalent to 13, and you replace with 13. But I was saying to avoid confusions, you can write the value the way it is. And again, it is controlled by the statement, the given statement. Let's say we're talking about these are number of people, isn't it? We're talking about we counted the number of people. You cannot say there were 12.5, isn't it? Let's say we're talking about people, my brother, or cars. Let's say we're talking about cars. You cannot say I saw 12.5 cars, isn't it? So even the given statement will guide you if is it possible to have a number with the decimal. I don't know if you follow, my brother.
Yeah, I follow, sir.
Yeah, so even the statement will guide you. I just wrote 12.5 there to avoid confusions, but even if you write 13, you convert to 13, can be still correct because the other values are not having decimals.
Okay, sir.
Yes. Yes. Come in.
So what's gonna happen if you have two missing values?
You know, we don't get to up to that level.
Okay.
Okay. We don't get to that level where we have more than it's out of the scope for level 3. So you should not worry about that one. So the next one, the next section, the last two sections that we need to cover next week Tuesday, it will be they're still under Latin square design. We're left with 3 sections. The next one that we're going to do is replicated Latin square design. We're still going to cover this one. Greco Latin square design. Jordan square and crossover. So we will do the calculations for this one, and this one. The ones with it, we are going to do the same everything that we did with the Latin square design. We're going to repeat it again for replicated Latin, Greco, Jordan. So the Jordan one, we just do the theory part. I won't do the application part. I will explain how does Jordan differ with Greco Latin square design. How does it differ with the normal standard Latin square design? So the Greco, just to introduce you to these things, because I noticed that time is no longer on our side. The Greco Latin square design, you are going to have 3 blocking factors. You're going to have 3 blocking factors. Replicated Latin square design, you still have 2 blocks. But in each and every cell, it's possible that you can have more than 1 value. So I will share the notes with you guys, which are connected to all these sections. The notes are there, they are ready So I will share the notes. Please go through those notes. Why am I saying this? So I will share these notes, guys, with you. So please, it's your responsibility to go through the notes. Wait, what's happening now? I'm trying to share the file that I'm talking about. This is the file, guys. Again, you will check if I covered all the questions here. Oh, thank you very much. I forgot to talk about what? I forgot to talk about the confidence intervals. I forgot to talk about, because if you check, you managed to write the model, you managed to construct an ANOVA, you managed to test, was blocking, test the effectiveness of blocks. We did that. Calculate the estimate of the treatment. Mr. Smanga gave us a hint on how to do it. We managed to do pairwise comparison using Duncan and multiple range test. But you know, we still have the take method and student Newman curls. I nearly forgot to explain the confidence interval part of all this. So, guys, you know that you can also do the confidence intervals. The procedure is still the same as the other chapters. I showed you how to construct the confidence intervals. So the same procedure that I showed you last week, you continue with that procedure. For example, LSD. For example, when we use the LSD method, I'll show you when we use the LSD method. I just want to conclude. So the other part that I'm talking about, guys, they are here. You see, I gave you that formula to estimate the missing value. Here it is here, where T represent the treatments. T, the capital T represent the treatment totals corresponding to the missing observation, right? R represent the totals, row totals corresponding to the missing observation. C represent the column totals corresponding to the missing observation. Small letter t is the number of treatments in a Latin square design. So what I was saying, guys, is here, I said to make it red even here, after replacing the missing observation, missing value, after replacing the missing value, the analysis can proceed as for balanced Latin square design with the degrees of freedom for SSTO being t squared minus 2. So the procedure for calculating is the same. The only difference comes when to what? When you want to find the degrees of freedom of total. It's no longer t squared minus 1, it's squared minus 2. And then you
So,
do the
sir,
pairwise comparison. Yes.
how is it going to affect the SSE?
Degrees of freedom of SSE will be affected.
How is it the formula going to change?
Yes. Remember, my brother, no, it's going to affect the MSE, sorry. MSE. MSE. Why am I saying this, Tato? Like based on the example that we're doing now, right? Let me go back to that example. Cut. Are you there?
Yes.
Suppose this was our example. This one. This it shows that this is a 4x4 problem, isn't it? If this value, if we're having a missing observation, if we're having a missing observation that 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Let's say this is our problem, isn't it, Tab? You see the last row there is having only 3 dots, isn't it?
Yes.
So it means we have a missing observation here, isn't it? We have a missing observation here. Give me the degrees of freedom of total. Based on this, it's a 4x4. It's a 4x4 problem. What are the degrees of freedom of total?
16 minus 1.
No, there's a missing observation, Third.
Oh, it's gonna be 15 minus 1.
Third. T squared minus 2 is what? Third, I just explained now that when you have a missing observation, the degrees of freedom will change to what?
Oh, t squared minus 2.
Which is what?
So 14.
14. Degrees of freedom of treatment is still 3, right? It's still 3, it's still 3. What degrees of freedom of error now?
Oh, so I understand now. It will be 5.
What? To be 5, right? So it means this
Yes.
value, this one will be fine, but this will be affected, isn't it? This value will be affected because now we're no longer dividing by 6, we're dividing by 5. Do you understand that?
Yes,
So
sir.
this part won't be, don't think this part won't be affected, but this one will be affected. This one here. So can because I don't want to, because for someone who's going to download the notes will be confused if not the person decides not to listen to the recording. So allow me to remove this part to avoid confusion. So please guys go and do the go and check these notes. It's 3 past now. Everything that you need, guys. So if you want to check this section before Tuesday, please do so, because Tuesday we are going to complete chapter 5, and Wednesday we'll start chapter 4. Start with chapter 4 on Wednesday. So Tuesday, first session, we'll do the remaining sections here. So you have to be strategic here, guys. You just have to be strategic, because I'm going to share this note with you. I know you are writing tomorrow. You are writing today. You are writing today. Use the weekend to do what? To read these notes. This is a Gray-Collatin square design. The logic is the same as what? As the one that we're dealing with now. It's having what? Three blocking variables. You block by Greek letters and you block by row and column. So the new thing that you see here is what? Is the Greek letters. So the Greek letters represent what? The third block. And then treatment are still represented by what? By the letters A, B, C. The ANOVA table, you test for the treatment, Greek letters, row, and columns. But you just go through this example. Next week, we'll do it together on Tuesday. Your then square design, I'll also explain there, but don't expect any calculations for this design, your then square design. Just know the theory part. And the last one will be crossover design. It's still a Latin square design. So I will be able to finish all these things on Tuesday. So please, when you have time over the weekend, just go through the notes. I thank you. Enjoy.
Sir,
Yes. Yes.
for the test is chapter 3 and 5, ne?
We don't know.
Okay.
We don't know so far. Agree, we're writing on Friday, and on Wednesday we're still going to teach. So it will depend on what will be covered before Friday next week. Did I answer a question, Mrs. Monk?
Thing is that I went to consult with Mr. Elwo, then he said we write those chapter 3 and 5.
So it was a trap. Why is now are you asking me if Mr. Elwo said something else?
I just wanted to confirm.
No, it will depend what will be covered by that time. So suppose, Mr. Smanga, we fail to cover crossover design, and Mr. Lobo said it's 3 and 4. What is going to happen? So it will depend what will be covered by that time. Do you understand, Mr.
Yes, sir.
Thank you very much. Good luck for the afternoon test. See you next week, Tuesday. Thank you.
Sir.
Yes.